Let's work on our first hypothesis together. A published study states giving students chocolate prior to teacher evaluations increases teacher scores. Since a teacher had 3 sections of the same class, students were randomly split into 2 groups, where one group received chocolate from the professor and teaching staff, and the other group received nothing. Does chocolate appear to improve mean teacher scores? Okay, so one thing I want to note before we look at this null hypothesis, the reason that this is going to be a 2-sample t-test is I have 2 separate groups. So I have all the people in the chocolate group and the score that they gave. So I have one data value for each of those people. And then I have the no chocolate group and I have one score, one data value for each of them. So I have 2 independent groups, and for each group I have a single value for each person that's in it. Okay, so I've also given you this subtraction here for setting up the hypotheses, and I have it set as chocolate minus no chocolate. You can certainly do it the other direction. It just flips the sign on your alternative hypothesis. So I'm going to give you the subtraction each time just so that for consistency, it's easy for you to compare your answer and determine if you've gotten kind of the right idea here. So our null hypothesis is mu of chocolate minus mu of no chocolate equals 0. So there's no difference between the average score that the chocolate group gave versus the no chocolate. All right, so let me show you how this tip works. So the way I start this out is I take mu of chocolate on one side and mu of no chocolate on the other. And I mirror it to how the subtraction works. So chocolate was first, so chocolate is on the left. No chocolate was second in the subtraction, so it's on the right. The problem says, did chocolate appear to improve mean teacher score? So we're expecting the mean from chocolate to be bigger. So I've drawn in the inequality sign, and kind of depending on where you went to school for elementary school, some people teach it as like the alligator is eating the biggest number. So that open side of the inequality should be headed towards the number you think is bigger, which is in this case, we think the mean for chocolate is going to be bigger. All right, so now I need to get mean of chocolate and mean of no chocolate on the same side. So I'll subtract the no chocolate one over. So it looks like this. I've subtracted mean of no chocolate from both sides. And so what we get is that the mean of chocolate minus the mean of no chocolate is greater than 0. Okay, and so that's our alternative hypothesis. So my null was mu of chocolate minus mu of no chocolate equals 0. And my alternative is mu of chocolate minus mu of no chocolate is greater than 0. So let's do a general version of this. If the number that is listed first with the mean is something you think is bigger, then it's just going to be greater than 0, and this will be a right tail test. Okay. All right, so let's look at a left tail version. During the first 3 months of a training program, a new cashier was timed for the number of items per minute that they rang up on 18 randomly selected occasions. In the same time period, an experienced cashier was timed for the number of items per minute they rang up on 14 randomly selected occasions. Test whether an experienced cashier will be able to outpace a new cashier. So again, we have 2 distinct groups here. You'll notice they're not even the same size. So that's definitely an indicator that you're in a 2-sample t-test. And I have the subtraction set as new minus experienced. So our null hypothesis is the mean of the new minus the mean of experience is equal to 0. In other words, they check people out at about the same rate of speed. Okay, and then let's look at how to structure that alternative. So I think that the new person, the way this is, they say the cashier, the experienced one is going to outpace them. So they're faster. So it means the new one is going to be slower. So I have the mean with the new is smaller than the mean with the experienced. And then I need to move that mean with the experienced to the other side. So I'm moving everything to the left side of that inequality. And so if I subtract the mean of the experienced from both sides, I get mean of new minus mean of experienced is less than 0. So my null hypothesis, mean of new minus mean of experienced equals 0. And my alternative is that the mean for the new minus the mean for the experienced is less than 0. So if that first number with the mean that you list, you think that it's smaller than the other number, then you're going to get that less than on a left tail test. All right, so you have a few more to work on. Go ahead and pause the video and see how you do with those alternative hypotheses. All right. A microbiologist wishes to determine whether there is any difference in the time it takes to make yogurt from two different starters, Lactobacillus acidophilus, which we'll call A for short, and Bulgarius with B for short. 7 batches of yogurt were made with each of the starters, and the time in hours to make each batch was recorded. So my null hypothesis is mu A minus mu B equals 0. So those two means are the same. And my alternative, it's asking whether there is any difference. So it could be smaller than, it could be bigger than. So we're looking at a two-tailed test here, and our alternative is mu of A minus mu of B does not equal 0, meaning those two means are different. Automobile insurance is used to pay for any claims made against the driver in the event of an accident. This type of insurance will typically pay to repair any assets that your vehicle damages. A random sample of those ages 30 to 59-year-old results in a mean claim of $3,699, while an independent random sample of 20 to 24-year-old drivers results in a mean claim of $4,586. Does the data provide justification that 20 to 24-year-old drivers should be charged more? So we're going to start with the 30 plus, and then we're going to subtract the 20s. And so this looks like we're saying that the 20 to 24-year-olds are going to be a higher mean. They're going to pay more. So that first number is smaller, and the second number is bigger. So this should be a left tail test. And my alternative is that the mu of the 30 plus minus the mu of the 20s is less than 0. And our null is the same as always, that they're just equal. So we get an equals 0. All right. Do people walk faster in the airport when they are departing or when they are arriving? The walking speed of travelers at DIA was measured. Is there a difference in the mean walking speed of departing versus arrival? So our null is that the mean of the departing minus the mean of the arrival is 0. And we're being asked, is there a difference? So that's sounding like a not equal to. So my alternative is mu of departing minus mu of arrival is not equal to 0. And that's going to give me a two-tailed test. All right. Oops. Too fast on that one. Coffee stations and offices often just ask users to leave money in a tray to pay for their coffee. Unfortunately, many people cheat. Researchers at Newcastle University replaced the picture of flowers on the wall behind the coffee station with a picture of staring eyes. They wondered if the average contribution increased when people felt they were being watched, even though the eyes were not real. At the 5% significance level, is there evidence the mean contribution increased if a picture of eyes was posted rather than a picture of flowers? So we're using eyes minus flowers, and we think that these eyes are bigger. That mean for the eyes is going to be bigger. So my alternative hypothesis is that the mean for the eyes minus the mean for the flowers, smaller number there, is greater than 0. So this is going to make this a right tail test. And then our null is always just the mean of the eyes, or mu of eyes, minus the mean of the flowers is equal to 0.